It's called the Great Silence. When we look into the heavens with the specific intent of detecting other alien life, whether intelligent or just a biosignature, we so far see almost nothing. There are a handful of candidates, of course, but none can be proven, and it simply remains that we have never detected any real evidence of alien life in the universe. Why is that? This has led to some questions about what if we actually are alone and represent something utterly unique, the only form of true consciousness in the universe. While cases can be made for why that might be, the case can also be made for how it almost can't possibly be so. In short, the argument is that there must be others. So here are 10 reasons to assume that we are not alone. Number 10. Organic chemistry and repeatability. The universe abhors a one-off. Overwhelmingly, whenever you see something in the universe, it tends not to be unique at its most basic level. If you find an object, whether a star or a galaxy or even a rock, you tend to find other examples in a similar class. Never absolutely identical, but enough to classify them. The reason for this is that the universe simply allows for what it allows for, and it clearly allows for us. So there are so many chances for similar things to happen twice or 3 times or many times, the sky could be the limit. But the rules are the rules, and wherever you look, whether it's stellar physics or biochemistry, the reality is that very specific rules apply. Things can get extremely complex and difficult to work out how they happen, but once you do, it becomes a known process that you can predict. This extends all the way up to the biochemistry of life. If it happens on one planet, it's overwhelmingly likely to be part of a population of planets across the universe where life has occurred. As a result, there just isn't a reason to think that life on Earth is a one-off, and the process never repeated anywhere else in the entire universe, despite literally every other aspect of the universe doing so. At least at the microbial level, it's overwhelmingly likely to have repeated somewhere. But that's life. Intelligence is a different story. Here life has to jump through a number of hoops to get to us, but we also know that we have a lot of intelligent animals on this planet that aren't far from our level of intellect. And indeed, we aren't the only species of humans. There have been in the past other species of human that were very close to us. We as Homo sapiens are just the latest incarnation of human intelligence on this world. And then we have the other intelligent species, which range from the octopus to the gorilla and even some of the birds, which all have very different evolutionary paths, yet ended up smart, independent of each other. And it's anyone's guess just what general intelligence on this world will do in the future. Some of these species may become even more intelligent still, with the passage of time and further evolution. The case is sometimes made that the most complex thing known in the universe is the human brain, but that can only be said because we've never met anything more complex than we are. There's nothing on this planet that can equal us, but that doesn't mean there aren't superbrains out there among alien civilizations. So in the end, the better bet is that human intelligence is simply part of a population of such things spread across the universe. Technological civilization might be exceedingly rare, but maybe it isn't, and we just haven't seen it yet. We simply don't know the answer here, but there really isn't a reason to suspect that we are alone. Number 9. Life is resilient. We often view life on Earth as delicate, having evolved to fill niches that are very specific. If something changes about those niches, life either adapts or it goes extinct. At first, that would seem to be the rule of the entire universe, where any life must necessarily face extinction if its niche no longer supports it. And look at our own civilization. Just to travel to the moon requires us to send a capsule of Earth's atmosphere and environment just to keep some very delicate humans alive. But then you come to the very odd instance of how one of the major concerns we have regarding staying alive in space, which is radiation exposure, has already been dealt with by some of Earth life to an extreme. And it wasn't through filling a niche or adaptation, but rather a side effect of evolution that can be imagined in other star systems as well as our own. Within this story are 2 very bizarre species of Earth bacteria that can do things no other life known on this world can do. The first is Deinococcus radiodurans, which is known as a polyextremophile, being able to handle cold, completely drying out, and even has been observed to survive in space, opening up the possibility that this could be a spacefaring organism in some capacity. One of the things it does best is survive astonishing amounts of radiation, thousands of times more than what would kill a human. It appears that all it needed to do in order to gain that radiation resistance was evolve the ability to dry out. It appears to be nothing more than a part and parcel side effect of that process of evolution. Learn to dry out, and it might inadvertently let you survive in space. But then we get to a deeper mystery that sounds more like a science fiction story than a fact, but it is indeed a fact. The story begins in 2003 when samples were taken from an oceanic hydrothermal vent in very deep water off the coast of California, and a strange species of microbial life was found named Thermococcus gamma-tolerans. This bacterium handles heat extremely well, but for some reason it can also handle extreme amounts of radiation, hence the name gamma-tolerans. This should not be. A dose of 5 grays of radiation will kill a human, sometimes even less. Yet this organism can remain viable after a whopping dose of 30,000 grays of radiation. Compare that to E. coli, which dies at 60 or so grays. How it does this is that it is able to very rapidly repair damage to its DNA done by radiation. How this came to be, and what advantage it might give the organism deep in the ocean is unknown, but maybe another side effect of some evolutionary process. Because of this ability, learning from this microbe may unlock things like slowing or even stopping the human aging process. The point is, life on Earth isn't just resilient by need, but it can be astonishingly resilient by accident. And we don't know what accidents are possible in biology that we haven't seen here on Earth. As a result, it could easily be that we're on the weak side of biology, and that there may be far more robust life out there in the universe, favoring intelligent life being more common than we might suspect. Number 8. The question of habitability. One point that's often raised is that while we have seen numerous other exoplanets, none of them have been all that much like Earth. But this actually doesn't mean much when you get into the specifics of why that is. It could simply be due to an observational bias or limitation. Unless it's close and unless it's not lost in the star's glare, it's actually very difficult to spot small rocky exoplanets. So while we haven't seen a true twin of Earth, we also might not have the instrumentation we need to realistically do so. That's set to potentially change as the James Webb Telescope makes its observations. But there's another aspect to this. We have been revising just what habitability for a planet actually means. We know what it means for Earth, and we have always used this world as a reference. But we've also found hints that Venus and Mars could have microbial life. And then there is the plethora of ice shell moons that exist in the solar system and may also harbor life, like Europa, that could have life in their subsurface oceans. Europa-like moons do not appear to be anything close to rare, or at least they aren't in this star system. And ice shell moons very much outnumber oceanic worlds. We have only one current one in this system, but numerous ice shell moons, which means most of the liquid water in the solar system lies under shells of ice. We don't yet know if anything lives in these environments, and indeed it could be centuries before we know about certain ones, like Ganymede, where accessing the ocean would be difficult. But even if just one has an independent occurrence of life, then habitability becomes a whole new question. And it's a rather sad one, because if most of the inhabited exomoons in the universe make up the majority of life-producing worlds, then it's unlikely we will ever know about most of them. They are just too small to detect and impossible to study for life. Number 7. The sheer amount of habitable stars. Now, the habitability of ice shell moons is also interesting in that they can theoretically exist under a wider range of conditions and stars than a world like Earth can. Indeed, it's possible through heating by radioactive decay for an ice shell rogue planet to be habitable even though it lacks a star. But as to Earth-like worlds, the vast majority of the stars in the universe, at least according to current understanding, could host a water world like Earth. Even more for ice shell moons. This ranges from the ubiquitous red dwarfs, which for a while were thought to disfavor life due to flaring, now show that flaring doesn't happen at the latitudes needed to destroy planetary atmospheres. So the 3 most common types of star in the universe, accounting for over 90% of all stars, can in principle support an Earth-like planet, and even more could support ice shell moons. That could mean that worlds with liquid water may potentially be among the most common objects in the universe. As a result, that gives an overwhelmingly huge chance for life, and indeed also stands in favor of the existence of other civilizations. The sheer mind-boggling numbers involved could easily reach into the sextillions of liquid water worlds within the observable universe. It's impossible to say for sure right now, but it may possibly even be the case that they outnumber the stars themselves. Number 6. Maybe we don't know how to look. How would you recognize an alien civilization if you saw one? We've only recently been able to even ask that question, and if you asked anyone from just a century and a half ago, their vision of an alien world would now seem quaint, with inhabitants of the Moon and Mars being common themes. That was until we learned more about those places. But coming with that, particularly Mars and Venus, while jungles and civilizations aren't there, microbes might be, leading to a whole new paradigm of how we view the possibility of alien life in the solar system. They are microbial if they are there. Well, unless some vast ecosystem underlies the ice of Europa or Enceladus. But again, this thinking in time-sensitive paradigms is probably still with us, and it might be so bad that we simply wouldn't recognize an alien civilization's activities from afar if we saw one. We might dismiss it as nature, or it may even be that alien civilizations make their presence known through technology or means we've simply never thought of yet, and once we do, the whole galaxy could light up with contact through some means that aren't technosignatures as we currently envision them. And there's already some evidence for these kinds of paradigm shifts. The once much discussed Kardashev scale, for example, envisions the activities of civilizations based on their energy collection and consumption. It's still a useful thought experiment, but the truth is we don't really look very much like we're going in the direction of becoming a classically envisioned Kardashev Type 1 civilization. We do still use ever more energy, but we can also envision new energy sources such as fusion that mean we simply don't need to build gigantic energy collectors in space. So maybe there is a paradigm shift there, and maybe there will be more. And someday we might feel embarrassed if we managed to not spot aliens simply because we didn't know what we were seeing until we did it ourselves. Number 5. Anthropocentrism. We look out into the heavens and ask ourselves, are we alone? But we don't ask ourselves as much if someone is watching us wondering the same thing. We only very half-heartedly and rather unrealistically sent out news of our existence. It's not too likely that anyone will ever find a gold record we sent into space, nor does anyone further out than 100 light years know that there is a technological species here emitting radio. But even then, they'd need some very serious equipment to ever spot us, even as we broadcast now. But then there were signals that anyone could have seen that happened to be in its path, the Arecibo message. But we only sent it once, and everyone would need to know to be looking for it when it passes by them, but they have no way of knowing about it ahead of time. We are someone else's wow signal at best. But there is another side to this coin, that aliens even ask that question. Might they assume that they are alone and be done with it? Or assume that they aren't alone and be done with it? That may be good enough for them. Or they may never ask at all, finding other life in the universe irrelevant for some reason. After all, how many species on Earth are there currently wondering about the existence of aliens? Only one. Our cats and dogs simply don't find the subject relevant to them, as they lack the needed brain physiology to even wonder about it. But maybe aliens lack that as well, despite being intelligent, or they lack curiosity. So maybe a simple solution to the Fermi Paradox is that we're simply weird in the questions we ask, and the rest of the galaxy just doesn't transmit anything that's detectable at a distance. No one ever builds giant omnidirectional radio beacons because they aren't really of interest, or aren't necessary to anyone but humans. Yet we ourselves have yet to really send any kind of signals that have a realistic chance of being intercepted. Maybe no one ever does. Perhaps the universe teems with intelligent life, it just doesn't ever interact between individual occurrences. Number 4. Do we all exist at the same time? This is actually another really simple solution to the Fermi Paradox that doesn't really get much attention. But it should, because it's amongst the most reasonable solutions out there. It goes like this. Civilizations are relatively rare but not unique. But they may not last long. They may run up against resets or even extinction, or social strife that resets their civilization periodically to Stone Age-like conditions. Or there is simply a finite time in which a civilization exists as something recognizable as one. It may simply be that the average lifetime of a technological civilization is 500 years or 10,000 or say 500,000 years, just to toss an arbitrarily huge number on it. Even at 500,000 years, it may not be enough time for two civilizations to commonly exist within the same galaxy at the same time. The answer to the question is yes. You are alone, at least in your galaxy, at any given time on average, but you are not alone in time, and many have existed before us, and many more will exist after us. Strangely, though, there is a loophole here, a really strange one, and that brings us to number 3. All aliens have traveled to the future. Another neglected solution to the Fermi Paradox is actually a really weighty one. It may be so simple that it's just the theory of relativity. In relativity, you have the reality of time dilation, either through acceleration or gravity. These effects are real, and we have to compensate for them with our GPS satellites. Time dilation can be measured in the lab, even on very minute scales. So the idea is that you can manipulate the passage of time simply by gravity or acceleration. The effect is the same. So say you jump in a rocket ship and you have the energy to get up to relativistic speeds. You will, from your frame of reference, step out of your rocket ship far into the future from where you started. It's a simple reality of nature that is well proven. But what if everyone does that, and that all past civilizations in the universe have basically time warped themselves to a much later period of time in the universe, and we can only at best transiently see them as they pass through our frame of reference? Perhaps they do it in intergalactic space, where we have little hope of ever spotting them for lack of knowing where to look. Do we even know to look for relativistic alien civilizations? So in a sense, all past aliens lie in our future, and at some point, if we go relativistic, all of a sudden we meet everyone at some future point in time when they've stopped traveling. Perhaps that's what you do. You just travel forward in time at relativistic speeds until you see someone at some ideal point in the future. And what comes with this is that by doing that, you will have traveled most of the width of the observable universe in a lifetime, covering a lot of ground to search for others. Number 2. The very large universe. One of the absolute guaranteeing possibilities that we are not alone is the idea of an infinite or even just much larger universe than we can see. We live in a bubble known as the observable universe. Beyond it, we simply can't see because the expansion of space collectively overcomes the speed of light, and the light from those parts of the universe can't get here fast enough to counter the expansion rate of so much space. As a result, we don't actually know how big the universe actually is. It could be that it's only a little larger, and that we see most of it from our perspective, but it could also be much larger, orders of magnitude larger, and some have even suggested infinite. The bigger the universe, the more stars and planets and moons and chances you have for life, and intelligent life, to arise, all within the framework of time. This has the effect of increasing the chances, and at some point, it just becomes a ridiculous notion for us to be alone, even within the observable universe, but more so outside it. There would simply be too many chances, infinitely so, for it to happen. Of course, there is no guarantee that what lies outside the observable universe is the same as within it, but there is zero indication that it isn't. Everywhere we look, the observable universe is more or less the same. So what lies beyond should also be more of the same, or something is very unusual about this universe. The sad thing here is that if our closest neighbors lie outside the observable universe, or even a distant galaxy, we will likely never know they were ever there. Number 1. Life in the multiverse. The multiverse is a very contentious issue. Suffice it to say, it just means that this universe is one of many in a greater latticework of perhaps an infinite amount of universes, or at least that's one take. The other being the many worlds interpretation, where the universe is constantly splitting off timelines and other universes. Both could be happening at once, very dizzying. But the idea of completely separate universes floating in a multiverse like bubbles in a bathtub is an interesting one, and solves some of the questions about our universe, including the infamous anthropic principle. But in the end, it doesn't appear to be measurable at this point, so we may never know if there is indeed a multiverse, and the debate goes on. But in the context of astrobiology, if such a multiverse exists, actually in either form, then the likelihood of alien life again rises, but this time existing in another universe entirely. Again, this would be non-interactive life, or so dramatically different that it may not even understand the same laws of physics and time we do. But it's an interesting thought that at what boundary do we place the definition of alien? Is something from another universe still an alien? Or does it need a definition of its own? Or how about life that existed in a previous universe before the Big Bang? Could that still be called alien? Let me know in the comments below. Thanks for listening. I'm futurist and science fiction author John Michael Godier, currently going to crazy town thinking, what about a multiverse of multiverses? What if they're not infinite, but instead shaped like turtles, and it really is turtles all the way down? I've always wondered what would happen if one poor turtle in the chain got tired and shook the rest off. Not good. And be sure to check out my books at your favorite online book retailer and subscribe to my channels for regular in-depth explorations into the interesting, weird, and unknown aspects of this amazing universe in which we live.